Hello everyone, myself Namita. My project title is Crowd Detection and Analysis for Surveillance Images using Deep Learning. Crowding is a common phenomenon observed during major events such as concerts, festivals, sports, games, and entertainment. And crowd is a group of people gathered in a certain location. Crowds differ in different situations, like crowd in a temple will be different from crowd in a shopping area. So that crowd detection and analysis will help to find a number of people present in a crowd, and it will play a crucial role in identifying potential risks or unusual patterns. Machine learning algorithms will be trained on historical data to recognize normal crowd behavior and raise alerts in the event and anomalies. This proactive approach will enable authorities to intervene promptly and prevent incidents from escalating. Density estimation, another essential aspect of the system, will provide insights into crowd distribution and congestion levels in specific regions of interest. This information inform event planning and infrastructure design to accommodate varying crowd sizes and ensure smooth crowd flow. Ultimately, the proposed crowd detection and analysis system is expected to contribute significantly to public safety and urban planning by offering real time insights, alerts, and data driven recommendations. The system aims to enhance situational awareness, optimize resources allocation, and create safer and more efficient public spaces for citizens, thereby making a favorable effect on the overall quality of urban life. And project description and new initiative called the crowd detection and analysis system aims to monitor IA an innovative project called the crowd detection and analysis system uses data analytics and computer vision to track, identify, and analyze crowds in a variety of settings. And new initiative called the crowd detection and analysis system aims to monitor IA. Modern algorithms are used by the system to analyze real-time video feeds or picture data, allowing it to recognize crowd patterns, density, movement, and behavior. The project's main goals are to improve crowd control, increase public safety, and offer insightful data for a variety of users, including emergency response, urban planning, and event management objectives. The primary objective of the crowd detection and analysis project is to develop intelligent and comprehensive system that can be automatically detect, track, and analyze crowds in a public spaces. Crowd detection implements state-of-the-art object detection algorithms to accurately identify and localize individuals within crowded scenes. The system should be able to distinguish people from the background and other objects present in the environment. Crowd tracking, advanced tracking algorithms to follow the movements of individuals across consecutive frames. The system should maintain consistent and reliable tracking even in highly crowded dynamics. Develop segmenting image methods to estimate crowd density in specific places of interest. The system should provide real time information on crowd distribution, congestion levels, and area with the potential safety concerns. And existing and proposed system, in existing system, the system may also incorporate anomaly detection techniques to identify abnormal or potential dangerous crowd behavior that require immediate attention. And many crowd analysis systems use machine learning techniques to improve their accuracy and adapt to different scenarios. For instance, supervised learning can be used for behavior classification, and reinforcement learning may be employed to optimize crowd control strategies. In crowd detection and analysis, people could feel discomfort knowing that their movements and behaviors are being monitored and analyzed without their consent. Require skilled person for analysis. And next, proposed system. In proposed system, analyzing a proposed crowd detection and analysis system involves assessing its effectiveness, efficiency, and suitability for the intended application. Evaluate the accuracy of the crowd detection model in identifying crowd regions in images. Measure its performance using common matrices such as precision. Recall FI score or intersection over union for box detection. For crowd counting, use matrices like similar to mean absolute error or mean squared error. The crowd analysis models accuracy in tasks like counting, tracking, or anomaly detection should also be measured. Feasibility study. Technically feasibility accesses the state of our technologies, research and determine the availability of existing crowd detection and analysis technologies including computer vision and data analytics. Hardware and infrastructure. Evaluate the hardware and infrastructure requirements such as cameras, sensors, processing units, storage and network capabilities. Scalability. Analyze whether the system can handle varying crowd sizes from small gathering to large events or urban areas. Real time requirements. Determine whether the system needs to operate in a real time, such as for live surveillance or monitoring. If real time performance is necessary, verify that the proposed hardware and software can meet the processing speed requirements. Scalability. Consider the scalability of the system to handle large crowds and long duration videos. Ensure that the system can maintain performance and accuracy when dealing with increasing data sizes. Cost and budget. Conduct a cost analysis to estimate the expenses involved in developing and deploying the crowd detection and analysis system. For hardware, software, data acquisition, manpower, and potential license fees. Tools and technologies used. Technology. PHP. A server side designed a programming language particularly for creating web pages is called PHP. PHP instructions are put directly into a HTML source document as opposed to making a server call used as the primary filter. Application development delivered on the web servers. Machine learning techniques. Machine learning is a subfield of artificial intelligence that focuses on the development of algorithms and statistical models that allow computers to gain experience based knowledge and enhance their performance on a given activity without having been designed explicitly for it. CSS. Cascading Style Sheet is a styling language used for advanced design for web pages, used with Bootstrap, used in HTML tags, and there are in three types: inline, internal, and external. And tools are Ajax. Ajax is a asynchronous JavaScript that an HTML website calls in order to build upon JavaScript. The request and the answer are sent using Ajax. WAMP. WAMP is an Apache server to run MySQL and PHP. It uses CGI, Common Gateway Interface. WAMP. And TensorFlow. It frequently covers a diverse arrays of tasks but has a specification in deep neural network inference training. TensorFlow might be a supported data flow. It can be distinguished by programming. GPI CPU computing, in which the same code is frequently run on both architectures. High performance computation across multiple devices and massive data set. And in it too, Pandas. Pandas is a well known Python data analysis toolkit. It has a direct relationship to machine learning. As a whole, we need to prepare the dataset before training. In this situation, pandas come in helpful as a developed for data preparation. NumPy, it used for numerical Python, which is a group of procedures for handling multidimensional arrays and objects. NumPy allows us to conduct logical and mathematical operation on arrays. This is an open source Python library for numbers. OpenCV is capable of image analysis and processing, and OpenCV Python has library Python bindings created and solves computer vision challenges. Keras. Python's Keras package is a well-liked machine learning tool. ML newcomers may easily build a neural network using Keras. The ability for quick and simple prototyping is among the finest feature. jQuery. There are some features. It is user friendly. It is interactable. It uses DOM events, effects and animations, Ajax, JSON parsing, extensibility through plugin. MySQL. The following are some of the features of MySQL database software written in C and C++, tested in all compilers. Platform dependency is less. Chapter 3, Software Requirement Specification. Software requirement specification for a crowd detection and analysis system outline the detailed functional and non-functional requirements that the software should meet. Here are some key components of the SRS for a crowd detection and analysis system. Purpose: clearly list the functional capabilities of the system such as crowd detection, crowd counting, crowd tracking, anomaly detection, and social behavior analysis. Specify the input data types including images, video streams, or pre-recorded videos that the system should support. Describe the expected outputs such as visualizations, analytics, or alerts based on the crowd analysis results. Scope: outline the performance requirements such as response times, throughput, and real-time processing for certain tasks. Specify the accuracy and reliability expected from the crowd detection and analysis models. Detail the security requirements to protect sensitive data and ensure data privacy. Describe the scalability requirements to handle varying crowd sizes and different deployment scenarios. Functional requirements. Crowd detection. The system shall accurately identify and delineate crowd regions in images. The system shall handle various crowd densities and lighting conditions. Crowd counting. The system shall accurately estimate the number of people in a crowd from images. The crowd counting algorithm shall work in a real time from live images. Crowd tracking. The system shall track individuals within a crowd over consecutive frames to maintain their identities. The crowd tracking algorithm shall handle accumulation and temporal disappearance of individuals. Anomaly detection. The system shall identify abnormal crowd behavior and unusual events such as sudden movements or overcrowding. The anomaly detection mechanism shall trigger alerts or notifications for further investigation. Social behavior analysis. The system shall analyze crowd behavior to identify social relations and interactions among individuals. Non-functional requirements. The crowd detection. The system shall Crowd tracking. The system shall track individuals within a crowd over consecutive frames to maintain their identities. Anomaly detection. The system shall identify abnormal crowd behavior or unusual events such as sudden movements or overcrowding. Social behavior analysis. The system shall analyze crowd behavior to identify social relations and interactions among individuals. Hardware and software requirements. Processor Exxon server or Intel Pentium, RAM 4 GB RAM, hard disk 500 GB, monitor 15 color. Hardware requirements in a client machine: processor Pentium and RAM 1 GB RAM, monitor 15, hard disk 500 GB. Software requirements: front end PHP, CSS, jQuery, server side Apache, backend MySQL 5.0.67 community. Tools used: Rapid PHP 14, SQL, Yog, Firefox, and FileZilla. FTP client. Operating system: Windows XP, Linux. And in system design, system perspective. The term system perspective describes the point of view or strategy that designers and developers use to understand, access, and create complex systems. To fully understand the system's parts, interconnections, and behavior, it includes viewing the system from many perspectives and degrees of abstraction. Context diagram. A context diagram for a crowd detection and analysis system visually represents the interactions between the system and its external entities. It provides a high-level overview of the system's boundaries and the flow of information between the system and its environment. Here is a simplified context diagram for a crowd detection and analysis. And In detailed design, the program's quality is essential to its design. User requirements are converted into a full solution during the design process. The goal is to design a system that considers all of the constraints imposed on it. Software design is the process of choosing the various system components and practicalizing user needs. Different subsystems are selected individually, designed, and then combined to ensure that the desired results were obtained. Use case diagram. A use case diagram is a detailed explanation of how various will use your website to complete tasks. Use cases: performance crowd detection. Description: the user uploads an image. For crowd detection and analysis, actor user. Preconditions: the user has access to the crowd detection system. Flow of events: the user uploads an images containing crowd scenes. The crowd detection system processes the input and detects crowd regions and individual people. The crowd analysis module analyzes the crowd for further insights. The results are generated and stored for further visualization and analysis. View crowd analysis results. Description: the user views the crowd analysis results generated by the system. Actor user. Preconditions: the user has access to the crowd detection system and has performed crowd detection. Flow of events: the user accesses the system interface. The crowd analysis results are displayed including crowd density maps, crowd counting results, tracking data, anomaly alerts, and social behavior analysis outcomes. Data flows. Data flow. In image 1, description represents the input data containing crowd scenes uploaded by the user for analysis. From user to crowd detection. Data flow: detected crowd regions and identified individuals. Description represents the output data of the crowd detection process, which includes detected crowd regions and identified individuals. From crowd detection to crowd analysis. Data flow 3. Crowd analysis results. Description represents the output data of the crowd analysis process, including crowd counting results, tracking data, anomaly alerts, and behavior analysis outcomes. Database diagrams and entity relationship. Diagram displays a relationship in entities. Symbols are used. The entity relationship figure defines that the relationships between entities in a database are illustrated graphically in entity relationship diagrams, which are employed in database design. It is a high-level conceptual model that aids designers and developers in comprehending the arrangement and structure of data within a system. Implementation in relation to software development or project management is a practical and concert execution of a concept, design, or planning to create a functional and product or solution. It involves transforming the theoretical ideas and specification established during the planning or solution. It involves transforming the theoretical ideas and specification established during the planning and design stages into a real world working outcomes. During these phase, developers or teams write code, build prototype, and assemble components, ensuring that the project comes to life and meets the intended objectives and requirements. Successful implementation requires meticulous attention to detail and adherence to the defined guidelines and good teamwork between members to attain the desired results. Once the implementation is complete, the project moves forward into subsequent stages such as testing, deployment, and maintenance or support. Screenshots. In home page, a snapshot defines a primary web page that a visitor will view when they navigate to a website via a search engine, and it may also function as a landing page to attract visitors. In admin page, the snapshot manages its configuration settings, content, and features, and carry out oversight functions critical to the business. In admin navigation page, the snapshot allows visitors to access the most useful pages quickly. In user login page. This snapshot allows a user to gain access to an application by entering their username and password or by authenticating using a social media login. In uploading images page, this snapshot will uploading the images to detect and count the number of people present in the crowd. Crowd detection checking. In this snapshot, it will count the live people in a crowd images. In software testing it helps for betterment of software and it to find faults in existing software. Type of testers: upload image upload. Description: verify that the system can correctly handle the upload of images for a crowd detection and analysis. Test steps: upload a valid image containing a crowd, verifying that the system successfully processes the uploading image. Crowd detection accuracy. Description: verify the accuracy of the crowd detection algorithm. Test cases and test steps: provide an image with known crowd regions, compare the detected image regions with the growth truth expected result. The detected crowd regions match the crowd truth with high accuracy. Crowd counting: verify the accuracy of the crowd counting algorithms. Test steps: provide an image with a known number of people in the crowd, compare the crowd count generated by the system with the ground truth expected result. The crowd count is within an acceptable range of the ground truth. Crowd tracking. Description: verify the accuracy and robustness of the crowd tracking algorithm. Test steps: provide a photo with multiple individuals moving in a crowd, verify that the system can track individuals correctly over consecutive frames. Expected result: the system accurately tracks individuals in a crowd without losing their identities. Anomaly detection: verify the system's ability to detect anomalies or unusual behavior in a crowd. Test steps: provide a photo with and social behavior analysis. Description: verify the accuracy of the social behavior analysis model. Test steps: provide a photo with various social behaviors such as friendly interactions or aggressive movements, verify that the system classifies social behavior correctly. Expected result: the system accurately classifies the social behaviors in the crowd. Crowd detection analysis software testing report. In first test cases: status, pass fail and comments. Image upload complete pass, system processed the upload images without errors. Crowd detection accuracy: complete pass, detected crowd regions matched the ground truth. Crowd counting: complete pass, crowd count was within an acceptable range. Crowd tracking: complete pass, system accurately tracked individuals in the crowd. Anomaly detection: completed pass, system generated alerts for detected anomalies. Social behavior analysis: completed pass, social behavior were correctly classified. Conclusion: the crowd detection and analysis system has passed all the test cases, demonstrating its accuracy and robustness in detecting, counting, and analyzing crowds in both images and images. The algorithm for crowd tracking, anomaly detection, and social behavior analysis performed well, giving insightful information and about crowd behavior. The system is deemed ready for deployment in real world scenarios and can effectively contribute to public safety and security in crowded environments. The crowd detection and analysis system represents a powerful and sophisticated solution for monitoring and understanding crowd behavior in various environments. Through the integration of advanced computer vision and deep learning techniques, the system can accurately detect crowds, count individuals, track their movements, and even identify anomalies or abnormal behavior. Future enhancement: In a future, enhancement for crowd detection and analysis systems can further improve their capabilities and address emerging challenges. Improved accuracy and robustness. Continue research and development to enhance the accuracy of crowd detection, crowd counting, and crowd tracking algorithms. Invest in training the models on diverse and representative datasets to ensure robust performance in various real world scenarios. Semant- Semantic segmentation. Integrate semantic segmentation techniques to identify different objects within the crowd, such as identifying specific objects or distinguishing between individuals and objects like bags or cards. Multiple camera support. Develop the system to support multi-camera setups for large-scale crowd monitoring. Implement techniques for crowd tracking across multiple cameras to provide crowd movements and behavior, enabling protective crowd management and preventing potential incidents. Behavior prediction. Introduce behavior prediction algorithms to anticipate potential crowd movements and behaviors, enabling proactive crowd management and preventing potential incidents. Thank you.